In this chapter, we're going to be talking about sequences and series. The first one we're talking about is arithmetic sequence. So here's our first example. It's talking about the seats in an auditorium, and each row has 2 seats more than the one before it. So it kind of is set up like this. So I want us to know if the first row is 10 seats, how many seats will the 8th row have? Well, one way to do that is just literally to write it out. So the first row has 10, the second row, the one behind it, has 2 more, and so on. So we're literally just adding 2 on every time. And that works out for some of these problems, but not all of these problems, because sometimes maybe it gives you information for, say, the first row, and then it wants to know information about maybe the 100th row or something like that. And so there is a formula that we can follow as well, and that formula is right here. So maybe pause this and write it down. And hopefully you've written it down by now. And here is what every single thing stands for. So this is the nth term. So let's say this is a sub 8. We're talking about the 8th term in this sequence. A sub 1 represents the first term, n is the number of terms, d is the common difference. And all of these things will make a little bit more sense when we do a few examples. And you do not have to memorize this formula. This formula is given to you on the formula sheet. It will be given to you on the quizzes and tests. So here's the first type of example that you could see with an arithmetic sequence. It gives you some numbers in the sequence, and it just wants to know what's the next 4 terms. And so we're going to find that common difference that we just saw in that formula, and we're just really just going to subtract the first 2 numbers. So 6 minus 2 is 4, and you can see that that's common with all of these numbers. And so for every single time, we're just adding 4. So the next 4 numbers are 22, 26, 30, and 34. For the next example, we want the first 5 terms. It gives us the first term, so a sub 1 is the first term, and it wants us to find the first 5. So the first one is 5, and our common difference is 3. So we're just adding on 3 each time. And that's it. For our next example here, we want the 17th term for a sequence with the first term being 4 and the difference being 3. Now you could write this out. You could write out every single term, but I do want to show you how to use this formula. So I'm going to write the formula again. So it's a sub n is equal to a sub 1 plus total number of terms minus 1 times that common difference. So we're just going to go ahead and substitute in this formula. So we're looking for a sub 17. We're looking for the 17th term in the sequence. The first term is 4. There's a total of 17 terms, and the common difference is 3. And we can just go ahead and simplify this and see that the 17th term is 52. So that's how this formula works. So sometimes this formula is really useful. Again, for this particular example, you could probably write out all 17 terms, or you could just use the formula. Here's the next one. So we want to go ahead and find the first term for a 12-term sequence. So this one, I don't know if you would really want to do this one without the formula. So we're going to go ahead and start with the formula again. So I have a sub n. Oops. Let's try that again. A sub n is equal to a sub 1 plus total number of terms minus 1 times that difference. Okay, so this says that the sequence ends with 57. So that's our final term. And you might want to just write that over here. So that would be a sub 12 equals 57. We know that n is equal to 12 because there's 12 terms altogether, and D, that common difference, is 4. So we can just go ahead and sub these in now. We're looking for a sub 1. We know that the total number of terms is 12, and our common difference is 4. So we have 57 equals a sub 1 plus, let's see, this is going to be 11 times 4, which is 44, and we're just going to go ahead and subtract that from both sides. So it looks like a sub 1 is 13, and I'm perfectly comfortable leaving a sub 1 on the right-hand side. In the next example, it wants to know what number term is 180 in this sequence. So we can see that the common difference here is 8. And so we can go ahead and, if you really wanted to, you could just keep writing out the terms and then count which one 180 falls, or we can use the formula. So let's go ahead and use the formula. Sometimes you write this enough times, you're just going to remember it. But again, you don't have to remember it. It'll be given to you on the formula sheet. So let's write down all of the information that it gives us. So we know that our first term is 4. That's a sub 1 is 4. We know that whatever n is, our very last term, is going to be 180. We need to find n. And our common difference, we're just going to take the difference of 12 and 4 and see that that's 8. So we're going to substitute everything we know. I have 180 for a sub n. A sub 1 is 4. Need to figure out what n is. And d is 8. So we're going to go ahead and solve for n. I'm going to distribute this 8. Combine like terms. Doo-doo-doo. Okay, so I have 184 divided by 8. Pause. I did not have this ready. I apologize. And so we get 23 for that one. So it looks like 180 is the 23rd term in this sequence. And this brings us to our final example. So we want to just fill in the middle terms here. So what we really need to do is find that common difference. So we see that our first term is 5, our last term is negative 51, and n is 5 because there's 5 terms here. I think it's always a good idea to start with this formula so we can substitute in the values. So I'm going to go ahead and substitute what we know. And we need to figure out what d is. So negative 51 is equal to 5 plus 4d. Go ahead and solve for d. So d is negative 14. So now that I know d, I can go ahead and find the other 3 values. So I'm just going to take 5 and subtract 14, and that's going to give me negative 9. Subtract 14 again, that gives negative 23, and subtract 14 again, and that gives me negative 37. And you can see if we subtract 14 again, we get the negative 51. So we're going to continue with all of this in class. See you then.